given 5.7 multiplied by 10 all over 2. This is in standard form, and you are told that you need to convert this back into its original number. What you would do is you would take 5.7 and you would look where the decimal place is. And 10 is raised to the power twice. So that means that this decimal point was moved twice. So you move it once, you move it twice. This is where the decimal place would be. And there's an empty spot here, so there must be a 0. So that means that, working this out, this will be 570. And this is essentially working backwards from what we did in our last video. Now, another example, if we're given 7.24 multiplied by 10 raised to the power of 4. Now we have to solve for this. 7.24 to the right. If this n was negative, that means I would have to move this decimal place to the left. But in this case, it's positive, so I'm going to move it to the right. I'm going to move it once, twice, 3 times, 4 times. This is where the decimal place would be. That means that there are 2 zeros here. So our number is 72,400. So I'm going to take 1.84, and since the 10 is multiplied twice, that means that this decimal place is moved twice to the right. So I'm going to move it twice. That means the decimal point is there. So that means it is 184. I'm going to do the same with 8.7. Now, 8.7 is moved 3 times. So I'm going to take the decimal point, move it 3 times. That will give us 2 additional zeros. So that's 8,700. Now I have my 2 numbers. Perfect. Now we're going to either add or subtract them, whatever the question's saying. So 184 plus 8,700 will give us 8,884. But that's not my answer. Then I have to take this and convert it into standard form. So I'm going to take 8,884 and do my decimal point, see how many times I have to move this decimal point in order for this number to be less than 10 but more than 1. So 1, 2, 3. I'm moving it 3 times. So 8.884 multiplied by 10 raised to the power of positive 3 because I'm moving it to the right. 3 times. So 8.884 multiplied by 10 raised to the power of positive 3. Now let's do a few practice questions. If I have 1.76 multiplied by 10, that is added to 6.43 multiplied by 10 raised to the power of 2. So we're adding 2 standard form statements. But first thing I would like to point out is this 10. Is it raised to the power of anything? Well, it is, because remember, everything is raised to the power of 1. So keep that in mind. We're going to take the standard form statement and we're going to kind of work backwards from it. So 1.76 and the decimal point has been moved once. So that means it's 17.6. And now for this statement, 6.43, the decimal place has been moved twice, so that means I'm going to move it once, twice. So that's 643. Now I'm going to take both of these numbers and add it in this case. So 17.6 plus 643, that gives me 660.6. Now, am I done? I'm not. I have to take this number and convert it back into standard form. And if you'd like to be reminded, standard form is in this formula, a multiplied by 10 raised to the power of n. A has to be equal to this. So a is bigger or equal to 1, but it is less than 10. So I'm going to take 660.6 and I'm going to see how many times do I have to move this decimal place in order for it to be more than 1 but less than 10. So 1, 2, that gives us 6. So 6.606 multiplied by how many times did I move the decimal place? It was twice. Now say if I'm given 8.4 multiplied by 10 raised to the power of 3 minus 1.7 multiplied by 10 raised to the power of 2. So then again, we do the exact same thing that we've been doing. We take the statement, the first standard the first standard form statement. So 8.4, and the decimal place has been moved 3 times. It's positive, so that means it's been moved. We have to move it to the right. So 1, 2, 3. Here's where the decimal place will be. So there's 2 zeros there. So that means it's 8,400. Now I'm going to do the same with this statement, 1.7. So the decimal place has been moved twice. So 1, 2. That means the decimal place is here. There's a 0 here. So that means it's 170. Now I'm going to take 2 of these numbers and I'm going to subtract them in this case. So 8,400 take 170 equal to 8,230. Now am I done? I'm not, because I have to take this and convert it back into standard form. So 8,230, I'm going to put a decimal place at the back, and I'm going to ask myself, how many times do I have to move this decimal place in order for it to be under 10 but higher than 1? I sound like a broken radio. So 8.23, and you don't necessarily have to add the 0 at the end. And how many times did I move the decimal place? Once, twice, 3 times. So that's 10 raised to the power of positive 3. And that is converting it into the standard form.